Hey everybody, this is Alex Merced and welcome to another episode of Gnarly Datawaves. This week we'll be talking about automatic data optimization with Dremio Arctic. Bottom line is, if you have Iceberg tables, if you put them in an Arctic catalog, you can keep them nice and crisp and well maintained in an automated fashion. How cool is that? But before we get to our feature presentation, again, I want to remind you that you can get your hands on the Data Lakehouse and try it out at no cost and no obligation by trying out Dremio's test drive by heading over to dremio.com and clicking on the test drive button. And also make sure to pick up an early copy of O'Reilly's upcoming book, Apache Iceberg, The Definitive Guide. Okay, again, slated for an early release next year. You can find an early copy right there by scanning that QR code. We have several episodes of gnarly data waves coming up, okay, such as unified access for your data mesh, self-service data with Dremio semantic layer. That's where I'll be just presenting about the semantic layer, okay, and how you can use that to execute a data mesh. How to easily migrate from Hadoop using AWS and Dremio, and how Memorial Sloan Kettering um, is accelerating cancer research using Dremio's Lakehouse. So you can actually see how they use that to assist in their data wrangling, so that way they can be more, they can speed up the process of basically saving people's lives. So make sure not to miss out any of those episodes. And again, we're going to be doing several events with AWS and Tableau. So if you're in any of these cities on any of these dates, make sure to join us, whether it's Chicago, Toronto, or New York. And we're going to be also at several different events across the world, whether it's Big Data London, Big Data and AI in Paris, Coalesced by DBT, and so forth. So if you're at any of these events, make sure to check out the Dremio booth and pick up some swag. And with no further ado, let's get on to our main presentation, where we're going to be going over an easy data lakehouse management with Dremio's Arctic automatic data optimization. Bottom line is we're going to learn how you can automated or automate optimizing your tables using Dremio Arctic. And to tell us all about that, we're going to have Jeremiah Morrow, who's a director of product marketing at Dremio. Okay, and Jeremiah, the stage is yours.
Hi, everybody. My name is Jeremiah, and I'm responsible for product marketing for Dremio Arctic. Today, we're going to talk about easy data lakehouse management with automatic data optimization in Dremio Arctic. Here's a quick agenda. First, I want to set the stage / level set with a brief history of the rise of data lakes, why we have them, what they're good at, and what they're not so good at. We'll talk about how data lake management has evolved over time with file formats and table formats. Then we'll talk about one table format in particular, and that's Apache Iceberg, and some of the data management capabilities it gives data teams. Then I'll give you a quick overview of how Arctic wraps those capabilities up and some of the capabilities that it adds to data lake management. And then we're going to end with a quick 5-minute or so demonstration of the data optimization features as they appear in Arctic and how to get started with them. Afterward, we should have plenty of time for Q&A. So just a reminder to put your questions into the Q&A box on your screen at any time. So we're going to start by going way back in time to the days of the enterprise data warehouse. Decades ago, we were primarily concerned with business intelligence and reporting on structured data from business systems in our data center. And the EDW was really good at storing and analyzing that data, and they could connect to BI and visualization tools and provide reporting in a fairly reasonable amount of time. But most of these early solutions were appliance-based, read expensive, and they struggled to scale with data volumes. And now we have all of this data coming in from outside of the data center, including mobile applications, social media, and connected devices and IoT, just to name a few. And the data is often semi-structured and unstructured, and the EDW was not designed for these data volumes. So a lot of companies adopted data lakes, first with Hadoop, with HDFS, and then with cloud object storage. And these solved a lot of the data storage issues. They were really good for efficient storing of large data volumes and a variety of data types. And they were also good for small scale exploratory data science projects with small teams of data scientists. But they struggled with enterprise grade business intelligence and reporting, particularly with concurrency, And so the data lake never really managed to replace that BI and reporting in the Lakehouse. And so this is really what you have in, I would say, 99.9% of enterprise organizations today. If you weren't born in the cloud, you probably have one or more data warehouses alongside one or more data lakes. And they're each kind of doing what they've always done. BI and reporting still primarily done in the EDW, and the data lake is still for data science. And if you have an important source or sources of data in the data lake that you need for a dashboard or a report, you generally need to move that into a data warehouse via ETL or ELT in order to give data consumers the ability to leverage that. The challenge with this architecture comes as more and more of our data, especially over the next 5 to 10 years, is really semi-structured and unstructured data that's landing in the data lake. And so how do we enable access to more of that data for our marketing teams, for our sales teams to be able to leverage without creating a really complex web of ETL or ELT pipelines that we then need to manage and maintain? How do we get rid of the data copies? And so the question on a lot of minds today is, how do I get the best of both worlds? What organizations need today is a data architecture that combines the flexibility and scalability of the data lake with the data management, data governance, and data analytics capabilities of the data warehouse. And they need that to be able to satisfy a range of requirements for data consumers and different analytic use cases, from BI and reporting workloads to executive dashboards to predictive and prescriptive analytics. And spoiler alert, we think the answer is a data lakehouse. So we've had query engines on data lake storage for a while now. That was obviously where Dremio got its start, and we're still really good at the self-service analytics directly on data lake storage. But we also have the core components of the data lakehouse here, the things that make it a house that sit between data lake storage and your query engines, and help you manage and govern your data lake as you would a data warehouse. It starts with file formats, and although query engines work with a variety of different file formats, Apache Parquet is a format that gives data teams a lot of advantages in terms of data storage and read efficiency, especially over formats like CSV. It's also open source, and it's supported by a wide range of platforms and engines. So it sort of fits into this open data lakehouse concept. But if you really care about performance at scale and easy data management, which are really two factors that have limited the data lake's ability to address enterprise-grade analytic workloads, then you're probably researching and considering table formats. Table formats build on file formats to deliver things like ACID transactions, data management functionality, and data optimizations, which we're going to talk about and show. And then you want to wrap all of those capabilities up into a Lakehouse catalog. And a Lakehouse catalog enhances and adds to table level data management and governance, and layers on top more data management functionality, as well as things like security and governance features, which is what most customers would expect from a data warehouse type of solution. And we obviously think that Dremio Arctic is a really great catalog that builds on top of Apache Iceberg in particular to make data lakehouse management very easy. So what does Iceberg bring to the table? Pun completely intended, by the way. Iceberg is an open table format that started with Netflix and now has extremely broad support from some of the largest technology vendors in the world, including but not limited to Apple, Google, Amazon Web Services, Dremio, Snowflake, Tabular, Cloudera, and more. It's purpose-built to manage and deliver high-performance analytics on massive data sets, And it achieves that performance while making data management much easier with a few optimization features. And we're going to talk about each of them individually. The first is partitions. Partitions groups similar rows together when writing a table, which ultimately improves query performance. Other table formats can do that as well, but Iceberg supports hidden partitioning, which eliminates the manual partitioning task for data teams. Also, data consumers don't need to know how a table is partitioned when they write their queries. Iceberg simply avoids unnecessary partitions, but partitions ensure that your data is being read optimally and accelerates query performance. The next is optimization. Say you're ingesting a lot of data, but it's coming in small file sizes. Maybe you have a streaming data use case, or you're doing some sort of micro batching where you're bringing a lot of tiny files in. You don't want to manage and maintain multiple tiny files, and your data consumers don't want to have to query multiple tiny files. And so Iceberg compacts that data into larger tables. So this obviously makes data much more easy to query, much more easy to manage. And if you use Dremio Arctic, you can set this on a regular schedule and then forget about it. That eliminates a lot of management overhead from your data team, who would generally have to do this manually without Apache Iceberg. And the third is the vacuum capability. So over time, your data lake will inevitably collect manifest files, manifest lists, old expired snapshots, data files that are no longer being used. But they're still taking up space in your data lake storage if you don't have a way to remove them. It also becomes much more painful to manage and maintain all of those different files. So Vacuum gives you a really easy way to get rid of all of those older files. And again, with Dremio Arctic, you can set this on a regular schedule. It'll run in the background without any other manual effort from you or the data team. Vacuum makes your resource consumption from a storage perspective much more efficient and optimal. So you're not paying to store a bunch of files that aren't in use anymore. So those are the three primary data optimization features of Apache Iceberg, and it's one of the big reasons why Iceberg is gaining a lot of traction in the market, both from a contributor perspective and also on the adoption and deployment side. And there's a catalog ecosystem that is rapidly evolving out of the data management capabilities to help companies take full advantage of their Apache Iceberg tables. And one of those catalog options is Dremio Arctic. So Arctic takes the data optimization features from Iceberg tables. It adds some automation by giving users the option to schedule things like compaction and garbage cleanup on a regular basis. And then as you can see from this graph, it also layers a number of other features that make this architecture a true lakehouse with the house components of the warehouse. And more. So the one that I love talking about is data as code. Data as code was built into Project Nessie, and it was really inspired by what GitHub has done to improve the process of software development. So it uses branches, tags, and commits to give data teams the ability to make changes to tables in isolation for use cases like ETL and data quality, as well as data science and experimentation. So we've gone through the ETL and data quality use case in a previous Gnarly Datawaves episode. Highly recommend if you're interested in seeing how that works and how you can very easily bring new data into your Iceberg table without interrupting existing workflows. Go check out that episode. And then coming in June, we'll actually be talking about how to enable your data scientists to explore and experiment with data on a transient branch without impacting your other users. So stay tuned for that one as well. A little bit of a spoiler for coming episodes. From a management and governance perspective, data as code enables all of your users to access a consistent and accurate view of your data in isolation without impacting any other users, which I guess is what isolation means, and without managing and maintaining multiple copies of the data. It's also great for version control. So by tagging specific milestones in a table's history and by using commits to make atomic changes and commit history to see who is making changes when, it's really easy to roll back to previous versions by pointing to a previous commit if you need to troubleshoot or recover from a mistake. Another massive improvement, and one thing that has really held the lake back from replacing the enterprise data warehouse is security and governance. And so I mentioned a couple of the governance tools from commit history and tagging to be able to see who's making changes to your tables. But Dremio also features fine-grained access controls, as well as integration with authentication tools like Okera and Azure Active Directory. Things that are really table stakes for an enterprise data architecture these days. And of course, all of this is built on open standards and technologies. We are very much in support of Apache Iceberg as an open table format. So all of your data is accessible by a wide range of tools and execution engines, so you can bring the right tool for the right workload, whether that's Dremio, Sonar, Spark, Flink, or another tool that's best for the workload that you're running. So hopefully that helps as you think about how to make your data lake more of a data lakehouse, and the tools that you have at your disposal to effectively and efficiently manage your data. And Alex Merced has recorded a demonstration of some of the automatic data optimization features in Arctic, so you can see how to easily get started with some of those capabilities. So Alex, I'll toss it over to you.
Hey everybody, my name is Alex Merced, developer advocate here at Dremio. And in this video, what I'm going to do is demonstrate how to set up automatic table optimization for any Iceberg tables you have in a Dremio Arctic catalog. Dremio Arctic is a catalog as a service from Dremio that is powered by the open source Project Nessie. This gives you several benefits. Project Nessie allows you to have commits at the catalog level. So not only do you have commits and snapshots at the table level using Apache Iceberg, okay, which gives you the power to roll back an individual table, time travel, but now you'll also have commits at the catalog level, which allows you to roll back an entire catalog. So if you have a mistake on 100 tables, instead of having to roll back each table one by one, you can roll back the entire catalog to an earlier commit. You're also going to have the ability to create branches and tags on the catalog level. So you're able to, one, isolate ingestion into the catalog as a whole and then merge those changes back in for the whole catalog, which enables multi-table transactions. Okay, on top of those multi-table rollbacks, so you can do just with the commits by themselves. And on top of it, you can tag the whole state of a catalog at a particular time in order for like reproducibility of ML models that might rely on multiple tables instead of having to tag multiple tables individually at the table level. Another really cool feature, not only just from having that Project Nessie catalog that Dremio Arctic provides, but also the services on top of that for data management that Dremio provides, including automatic table optimization. So basically when it comes to things like compaction and expiring snapshots, and just basically making sure that your Iceberg tables are in the tip-top shape, you can automate that whole process. So essentially, in my Dremio account, can create multiple Arctic catalogs. You might want to do this because maybe you're implementing a data mesh and would like to create a catalog for each of your different domains. Okay, so that way each catalog, each domain can then manage what data they have available, manage the governance of that data, and so forth. But I can take any of these catalogs that I've created, I can go inside of them, and I can click on their configurations, this is the catalog settings. Okay, and generally out here on the main page of the catalog settings, you'll find all the information you would need if you wanted to connect things like Spark, Flink to your catalog to do ingestion work and other types of work, such as your catalog endpoint, and so forth. But if you click here on configuration, you can then configure your cloud. So you'd enter in your cloud credentials, so that way it can run the compute to optimize your tables and tell it, in which bucket you would like to save any kind of logs regarding those optimization jobs. Okay, just to show you how that would look like. So here I've already configured it in this catalog, but if I go to another one, so let's say I go to Arctic 3 here, and I go to configuration, basically before you've configured it would look like this. So you can choose from any of the clouds you have configured with your Dremio account. Okay, once you choose that, so if I choose default, you can choose what size compute to use for those optimization jobs, where you want to store your logs. Okay, and then here you can put your access. You can either do it through an access key and secret access key, or what you can do is you can do it through an IAM role. Okay, and basically what you would do is you would attach a policy. You would take this policy, customize it for your needs, and then attach it to the role that's attached to your Dremio Cloud account. Okay, but once you have that all set up, so I'll go back to that other catalog. So, oops, yep, leave. Okay, I'm going to go back to that catalog where I have it configured. Now let's say I have a table. So in this catalog, I have this table right here, names. I can go here, click on to configure that table. And then here I can either just click the optimize once button and it'll just optimize that table for me. You could also do this with the Dremio Sonar query engine, which has an optimize command, which you can optimize Iceberg tables with. Okay, but I can optimize it here. And if I want to set it on a set schedule, so that way it automates that maintenance, I can click here on set schedule and I can set it to, every few hours, days, weeks, months, however I want, set with my target file size for how big I want the files to be that it generates when it starts compacting those files. Basically, what is the minimum input files? Because maybe, hey, you have a 100 meg file, but you don't want it to compact that, just the really small ones. Okay, so you can set minimum input size, you can set a minimum file size for what the output will be, and what the maximum file size for what the output would be. So it'll try to create 256 meg files by default, but at minimum, it'll create 192 meg files, but never more than a 460 meg file. Okay, so you can set those parameters, hit save, and then basically it'll just run the compute on that schedule. Okay, and now your tables will constantly have compaction, so any small files will be turned into bigger files, so that way you get much better reads on those Iceberg tables beyond the already amazing read performance you can get because of the Iceberg metadata and how it enables engines to do things like partition pruning, min-max filtering to get those better, crisper performance. So with that, my name is Alex Brissett. Again, I'm a developer advocate here at Dremio. Hopefully you guys enjoyed this. Go try out Arctic. We have several blogs with tutorials on how you can try out a Dremio Arctic catalog, or even just try out the open source project Nessie in a Docker container or in a Spark notebook. You can find all of those at dremio.com/blog. Thank you very much. Have a great day and enjoy.
Thanks, Alex. That was a great demo. Really appreciate it. And hopefully everyone can see how easy it is to get started with the data optimization features of Iceberg within Dremio Arctic. I do hope you'll give Arctic a try within Dremio Cloud. You can sign up at www.dremio.com/get started. Or you can reach out to me directly. I am happy to put you in touch with some of our solution architects who can talk you through how to get started with Arctic in your data lakehouse environment today. So thank you again. And now I think it's time for some Q&A.
Well, welcome back. I hope you guys enjoyed that presentation. Now it's time for you guys to ask any questions you have about Dremio Arctic, the auto optimization feature, or anything you'd like to ask questions about. Put them in that Q&A box below and we'll begin answering those questions. Again, next week, we're going to be talking about implementing a data mesh and how Dremio semantic layer can play a very pivotal role in implementing that data mesh. So make sure you come back next week for that. But yeah, I'll give everyone a moment to put in any questions that they have about optimization. Or again, you can ask anything about Dremio Arctic and whatnot. So I'll give a second for everyone to ask questions. But with that, let's begin with one question being sort of like, we have this optimization feature. Are there going to be any other sort of bells and whistles for Dremio Arctic users that'll be added in the future when it comes to sort of automating things for their tables? That's a question for you, Jeremiah.
I think we are adding things to the UI functionality so that it'll be easier to actually see. Right now, as you showed in the demo, the UI is very similar to what we have for Dremio Sonar. But yeah, I think also we are going to make it more automatic. So right now you're setting it as a schedule. In the future, it will run in the background without so much initial setup. But that's like six months to 9 months.
Cool. And okay, we have one question here. In datamesh, each domain gets one catalog, or one catalog for Iceberg and one for Hive. That is each domain owner will have n catalogs of his own. Okay, just kind of talk a little bit about what's going on there. That could depend on what your particular architecture looks like. Sort of the way we generally envision it is that basically one Arctic catalog holds Iceberg tables. Again, that might change in the future where it might be able to hold other things, but right now an Arctic catalog holds Iceberg tables. But the idea would be like, hey, you have the product department, and the product department has their own data product. They would want to have all their Iceberg tables in one catalog, so that way they can control those access rules in one catalog. Because each catalog can have its own sort of set of access rules, and they can have different people who are control that catalog. So that way, if that person who's the head of creating that data product, I probably should use a different department. Let's say marketing data product. Then what would happen is that person can set the access rules on that, but because they're separate catalogs, they won't be able to set rules on the other domains tables. So that way you still have that, make sure that you have those clear lines of who is setting what rules. So again, theoretically, you could say, okay, one domain, one catalog, but there might be needs where you might do more. So you might have n catalogs. Imagine like the marketing department is big enough where they might need some subcatalog. Okay, you might need a catalog for paid media versus social, and they're creating even more fine-grained data products. That might be a situation. Or you might have the opposite situation where the departments are big enough where, or at a size or at a scale where it might make more sense to have maybe two departments share one data product or something like that, that already work together pretty closely. It really is going to depend on your enterprise and sort of your data needs. I mean, generally data mesh you're getting into is when you get into that enterprise big enough where it's just, you're at a scale where centralized management of that data is just not going to work anymore. So you have to assess sort of like what granularity you need based on sort of the actual business functions of your business units, and who basically the group of people who are going to understand sort of how to model that data, who should have access to that data. And again, the marketing department might be too high level. You might need to break that up smaller, because basically the amount of data and who has the knowledge of that data may need to break down. So again, you have to kind of do that internal audit of sort of what your business units and who has that institutional knowledge within your business.
Yeah. I think Dremio can support either. It really just depends on your organizational strategy. And I think most companies would want to centralize that security, data governance, access control. And that would end up being one catalog or multiple catalogs, but managed centrally. Something like that.
Yep. Okay, let me hit that question answer. Again, if anyone has any other questions, but again, at the end of the day, like how you apply these technologies is really going to be depending on what your needs are. There's no, perfect way, because everyone's needs are different.
Yeah.
But again, generally, each catalog gives you a nice unit of governance and unit of bundling related tables.
I was just taking a look, going back to your previous question, in terms of like roadmap for optimization and cool features coming. Another feature that is coming in the sort of midterm, I would say midterm, like 6 to 9 months again, is auditing for optimization jobs, so that you can see who's running those. Just another way to see who's working with the data and who's making changes.
Got it. Okay, so bottom line, so like there's a theme here of just like not only letting you do the things, but giving you better visibility into the things. Always love the things, right? It's just such a useful term these days.
Yeah.
But with that, I'll give it one more run for any remaining questions. Again, we will, for those who are interested in the data mesh story, we will be doing more of that next week. And then we'll also have some other data mesh episodes coming down the road, and some more episodes on Dremio Arctic. We also have some episodes just about what's at the very beginning of next month. That's what's just new in Iceberg in general. So lots of really great stuff coming up. So make sure you keep coming up every week. If you can't attend the episode, make sure to listen to it on Spotify or on YouTube. Basically, you have access to the stuff, and also check out our previous episodes. Like last week was quite a jam-packed tour of the Dremio world, if you hadn't seen that. But let me go back to the Q&A here. But yeah, I think that answers all the questions. So I think we made it very clear. You can automate your tables, and you can do it with only a few clicks.
Awesome.
So Jeremiah, thank you once again for joining us here on Gnarly Datawaves.
Thank you,
And
Alex. Always a
we
pleasure.
look forward to seeing you again. I think we'll see
sure.
you again sometime next month, right?
This might be my last one before I have a baby.
Oh, that's right. So everybody, congrats to Jeremiah. Wait, here, thanks, Alex. Regarding data mesh, my question was much simpler. I'm a data product owner. I have Iceberg tables, so I get one catalog. Then I had some Hive tables or others. I cannot use my Iceberg catalog, so I have to create another on for Hive. It is a bit annoying. Oftentimes I name my catalog from, yes, so that is like a challenge where basically you have basically different types of tables. Like you can't necessarily co-locate Delta Lake tables, hoodie tables, Iceberg tables all in the same catalog, at least not at the moment. Again, I can't speak to the exact future, but in the future, what can be included in one catalog may change. But right now, Arctic catalogs are generally exclusively Iceberg tables. But again, there's also the Dremio Sonar internal catalog, and that spaces feature that allow you to kind of co-locate data from anywhere and any type. So, again, if you're also just using Dremio spaces, you could actually have, views that are based on Hive tables, based on tables in your Arctic catalog in spaces that basically detail your data mesh. So there's two different approaches. You could use sort of like those Dremio spaces from software in the Dremio software world, or you can use like the Dremio Arctic catalogs if you're going all Iceberg. Hopefully that answers that question. But again, yeah, always trying to try to unify all your data, especially across different types. This can always be a challenge. That's the nice thing about the Dremio semantic layer, which will actually be the core of our topic next week. Because at the end of the day, it's just basically you're organizing it on top of your data sources, instead of, you basically, it doesn't matter where the data lives. So you theoretically could have a space for your data product that has tables from your Dremio Arctic catalog, has your Hive tables, has Snowflake tables, has Delta Lake tables, all literally in one Dremio space from the Sonar internal catalog. But we'll have that conversation next week. So make sure to attend. Next week, we'll have that conversation. And with that, that will wrap up this week's adventure. My name is Alex Merced. Thank you, Jeremiah, for joining me this week. Again, you'll see this on Spotify and YouTube within the next 48 hours. And yeah, see you next week.